All right, we're going to go ahead and get started. Welcome to Advanced Kentucky's final content review session for AP Statistics. We are less than 24 hours now until the actual AP exam, so we are thrilled to have Bob with us today to do some last-minute review. My name is Aaron Timmons. I'm the Advanced Kentucky Math Content Director. I'm joined by our STEM coordinator, Dr. Sherry McGuffin, and we welcome everybody here to today's session. So let's go over just a few housekeeping procedures. First off, this session is intended for a Kentucky audience. However, I know that we have students, I think, from 24 states and 3 countries joining us today, including teachers. So welcome to all. We will do everything we can to make today an equitable opportunity to learn. If you are causing disruption to the session, however, you will be removed. So please make sure you are acting appropriately. Contact information for all of us are on this screen. If you have any questions after today, feel free to reach out to us and we will get right back to you. Your microphones will remain off for today's session, as well as your video. Please leave those turned off. Please utilize the chat feature in the lower right-hand corner of your Zoom window. You can direct questions to Bob, me, or Sherry directly, or you can pose a question to the entire group. We will make sure to monitor the chat and get your questions answered, either by Bob or one of us. So please make sure you are using that. Ask any questions as they come up, regardless if you're a student or teacher. We are here to answer those. And then kyap2020.com. This is your resource for all of our previous videos, as well as today's video will be posted by the end of the day. If you need any last-minute review or have any last-minute questions on a specific topic, feel free to go back and search our videos and get some help there. So that is it. So we're going to jump right in. I'm going to stop sharing my screen. So Bob, you are up. Give us a little introduction to yourself and then take it away. Oh, Bob, you're muted.
You gave me that little nasty message. I like that Zoom will give you that nasty message that lets you know that, hey, you forgot to unmute yourself. But here we are. So good afternoon, everybody. And this is the final countdown. This is a very exciting day. We have a big exam tomorrow. And let me tell you a little bit about myself and how today is going to work. My name is Bob Lochel. I teach right outside of Philadelphia. You can see where we are, pretty much just north of Philadelphia, about 20 miles. And you can have extra credit points if you can tell me who is the band that sang that song, The Final Countdown. I don't have anything to offer, but they are a true one-hit wonder. This is Europe. You can see it in the drum kit here, but this is The Final Countdown. So I've been an AP teacher since 2004, but I'm also an AP reader. I am one of many teachers around the country who read and grade the AP stat exams. And there's actually another person in here who was actually my table partner one year, Mr. Gemel. He was my partner one year in the reading. Hopefully his students are here, and I know you're well trained as well. Dr. McGovern is asking that if you would state your name, where you're from, and whether you're a teacher or student in the chat, that would be awesome. I'll be keeping my eyeballs on the chat as we go throughout the day. So why don't we take about 60 seconds to introduce ourselves in the chat. Many teachers here, fantastic. Mia's from Hopewell Valley. She's one of Mr. Schrager's students, right? Saucon Valley, that's close to me. Yeah, a lot of Mr. Schrager students. Some of my students, good. From all over. Who can win the prize for farthest away? Montana, Minnesota.
Someone registered from China. I don't know if they're here or not.
Well, that could be, I just saw one up there. I'm not quite sure where that would be from, but that seems like far away to me. And of course, thank you to our host from Kentucky, because that's what it's all about. Nathan is here, one of my students, fantastic. So we'll be using the chat today, and we'll be monitoring the chat, so feel free to pepper me with questions as we go throughout the day. So what today is all about, here's the agenda for today's review. This is our review and maintenance day. So this is kind of like training for the big game. Hopefully you've been training and working hard and getting ready for what's going on. Today we're going to go through 2 questions. Now these are questions that I've written that are designed to simulate the 25-minute questions that you'll see tomorrow. Keep in mind that tomorrow you're going to see 2 questions. One is 25 minutes with a 5-minute period at the end to submit your response. One will be 15 minutes, and that will also have a 5-minute time period at the end for you to submit your response. Pro tips, every time we answer a question, I'll present you with some pro tips, things to think about beyond just the questions and things to think about as you work throughout. And you might want to jot them down, because keep in mind that tomorrow is open notes. So organizing yourself and your workspace to leverage those notes in a reasonable fashion is going to be something that's going to be very helpful for you tomorrow. And also, we're going to do a number of polls today. So there's going to be times where you can submit your ideas, and there'll be opportunities to test your understanding, okay? And at the end, I will give you some tips for taking the 2020 exam, things you should be thinking about, okay? So here's the first of our two questions. If you don't have the question in front of you, that is perfectly okay. I'll read and browse through it together. So this might be a little bit small on your screen, but we'll take a dive into it. But if you did download them, it's this one that we're going to look at first. So let's take the deeper dive into it. This one is about a real estate analyst is studying housing trends in two large cities, Primeville and Thunder City. One measure the analyst plans to compare is the sale price of homes in the two cities over the past 12 months. To gather data, the analyst used a public website to collect random samples of sale prices in each city. 50 homes sold in Primeville and 100 homes sold in Thunder City make up each sample. And the data are shown in the box plots, or the dot plots below, with the sale price shown in thousands of dollars. So our first question is a fairly traditional one in the AP world. Compare the distributions of housing sale price from Primeville and Thunder City. This is not an unusual question, but you should know by now the pro tips here. You should know the drill. We're looking for center, shape, spread, unusual features. Some teachers call this SOX as the acronym. Some call it CUS as the acronym. I'll also tell you, be careful with the phrase approximately normal, especially if you're looking at box plots. These are dot plots, but if you were looking at box plots, be careful with approximately normal. Box plots do not do a great job of telling us about shape. They do a wonderful job of telling us about symmetry, however. And also mound shape is a good proxy and approximation replacement for approximately normal. Context, context, context. We're going to harp on that throughout this webinar, that you should always be talking about what's going on in a problem. And something I found that when I gave this problem to my students, if you're asked to compare distributions, make sure you're actually comparing them. I had some students who gave me a laundry list of things about Primeville and a different list about things on Thunder City, and never made the connection between the two cities. So make sure you're actually comparing them with words like more than, greater than, less than, same. So here's a model solution for this one. Both distributions of sale prices are centered around 400,000 and are roughly symmetric and appear mound-shaped. The distribution of sale prices in Thunder City, the range is about 400,000, is more variable than that of Primeville, range of about 300,000. And a couple things about this, it is perfectly okay to estimate some of these things. You're not being asked to plug these into a calculator and find all of the summary statistics. They're both centered around 400,000. That is perfectly acceptable. And I'm also estimating what the ranges are. Okay. Also, when I gave this to my students, some of them obsessed over talking about all the small little micro gaps they saw in the data. That's not necessary unless there is a large gap somewhere where there is a clear single or maybe two outliers. I'm not even going to mention those things. So don't feel compelled to discuss gaps or outliers if they don't obviously exist. See a question in the chat. Can we say Primeville is slightly right skewed? Let me look at Primeville. I don't know if I am sold that Primeville is slightly, it's pretty much roughly slightly left skewed. I guess I would be okay with slightly left skewed. I see what you're saying where there's more dots here on the left side, but I would be careful about looking for those sorts of things when maybe they don't exist. But I think if you're going to say some kind of skew in Primeville, left skewed is probably the way to go there. Okay. So now the next two questions talk about probability. One home is selected at random from those in the analyst samples, and we're asked two probability questions here. What is the probability the home sold for over $500,000? And given that the home was selected in, was sold in Primeville, what is the probability it sold for more than $500,000? So two different probability questions here. One is a little bit more sophisticated than the other. Here comes some pro tips. First of all, show work. Even if it seems obvious, like even if you had to roll an eye, show me the probability of a 5 is 1 out of 6. Naked answers usually lose credit and oftentimes don't get credit at all. Make sure you're showing where even obvious numbers come from. And there's no need to reduce or change the form of a numerical answer. I think as math teachers, sometimes we do a great job of telling students that you always have to reduce or always have to turn things into decimals. That's not necessarily true here. Unreduced answers communicate where the answer came from, and they're perfectly acceptable here. So let's take a look at our answers here. First of all, what is the probability the home selected for over $500,000? Note here in the stem of the problem, we are told how many homes there are. There's no need to count all the dots. We know that there are 150 total dots. Oftentimes, AP problems are set up so you don't have to do small things like add up all the dots. Make sure you're reading the question and see what's going on. So what's the probability it sold for more than $500,000? Well, how many sold for more than $500,000? If we draw in the graphs here, we see in Primeville and in Thunder City, we have some homes in both cities that sold for more than $500,000. Counting the dots easily, we see it's 7, actually 9 altogether, 9 over the 150. And that is a perfectly wonderful, acceptable answer. If you go on and say that that equals 0.06, that's just fine. But if your only answer is 0.06, that is going to lose credit. 9 out of 150 is the best answer because it's reasonable for me to know where those numbers came from. Okay. Next question here. Given that the home selected was in Primeville, so now we have an idea of what's called a conditional probability. What's the probability the home sold for more than $500,000? That given that piece means we only want to look at homes sold in Primeville. So I no longer want to look at Thunder City homes. I only want to look at these homes that are in Primeville. We're told there are 50 of them, and I can clearly see that there are 2 dots within Primeville that meet the requirement of over $500,000. So we have an answer of 2 over 50. So 2 probability questions there. I'll pause for a second. Any comments or questions on either of the probability questions before I move on? They're pretty basic and totally reasonable for this year, I feel. I wouldn't be surprised if we saw some kind of a table this year where maybe you need to find probability. Okay, now it's going to get a little more sophisticated here. So we have these 2 questions, and now we have a follow-up question. Among the homes in the analyst samples, are the events sold in Primeville and sale price over $500,000 independent? Explain your response. Okay, this is going to be the first time we are going to do a group poll. Mr. Timmons, I'm going to show the answers, then we can run the poll if that's okay. So I want to know what the rationale is here for independence. So I've given you 4 choices here. Are they independent? Yes, because the probability that you're in Primeville does not equal the probability of over $50,000. It's actually should be $500,000, guys. I notice this is a misprint now. I should say 500,000. So pretend that says 500,000. And part B is no, because the probability you're over 500,000 does not equal the probability of over 500,000, given that you're from Primeville. C, because it's it's likely that sale price is not dependent on city. Or D, no, because probability of Primeville does not equal probability of over 500,000. So I'm going to pause as we do the poll. Take a drink of water because I'm stumbling over words here. So Mr. Timmons, we can go ahead and start this first poll.
So the poll is anonymous. Feel free to give your best shots. Bob, while we're waiting for answers, someone asked, should we mention outliers only when clear?
Yeah, that's kind of a tricky thing, right? Because what you don't have to do is sit there and try to justify too much if something's an outlier. I'll just give you this general knowledge that if you suspect that something could be an outlier, it's probably okay to mention it, but I wouldn't go on an outlier hunt. But if something is clearly far away from everything else, I would mention the outliers. But don't stress if you're not sure if something appears to be an outlier, it's likely that it's probably not. We see that we have 87 people who have voted so far. Mr. Timmons, I'll ask you, do I have control of this box then? Is that what's happening with this?
You can end the poll, I think.
I can end the poll whenever I want? Okay.
So,
We
yeah.
can say potential outlier. Yeah, I see that in the chat. Potential outlier is just fine. Yeah, unless you're asked to, you do not have to prove the idea of an outlier. Okay, so let's end this poll. B seems to be the most popular, and that is true. This one is B. Because the probability of over $500,000 does not equal the probability of over $500,000 given in Primeville. So let's take a deeper dive into this one. Let's take a deeper dive into this idea of independence here. So some pro tips here. Okay. First of all, 2 events are independent. The general way to prove independence is the probability of A has to be equal to the probability of A given B. And in this problem, we are given the probability of A over 500,000, and we are given the probability of A given B. So if you apply these events, you are given these. And that leads me to this tip. Oftentimes we ask about independence. The work used to do independence is oftentimes done at least part way in the question before. So oftentimes these questions are scaffolded, where part C will follow based on part B. So if you look at what you're doing there and you look at what the answers are, well, there's a reason why you were given Roman numeral 1 and Roman numeral 2. They're the 2 pieces for independence. Now, this isn't the only way to prove independence. There's actually a multitude of ways to do it. I'm only going to harp on one other way that you could do that here. You can also prove the independence rule. The probability of A and B, the probability of a house being in Primeville and over 500,000 has to equal the probability of A times the probability of B. And the multiplication rule, the best idea of independence there I can give is like a die in a spinner. If I roll a die and I spin a spinner and I want to know the probability the die lands on a 2 and the spinner lands on a certain segment, you would just multiply their probabilities because they are independent events. But the first thing you see here, that first pro tip, is the most, how should I say, the most prevalent way to prove independence on the AP Stat exam. Okay. All right. The rest of the question kind of delves into inference now. So here's the next piece here. Using technology, the analyst computes a 90% confidence interval for the difference in mean sale price in thousands of dollars for all homes sold in the past year between the two cities. They did Primeville minus Thunder City. The interval is given by negative 18.997 to 19.397. So let's take a look at this student response. So here's a common student solution. Again, I gave this as a test to my students. This was a common answer. We are 90% confident that the interval negative 18.997 to 19.397 captures the true difference in mean sale price for all homes sold in the past year between the two cities, Primeville versus Thunder City. And if the students were asked to interpret a confidence interval, then I would call this essentially correct. But this is where you really need to read what the prompt is telling you to do. You're being asked here to interpret the meaning of 90% confidence. And that's in quotes for a reason. I want to know what it means to be 90% confident. If we're asked to interpret the confidence interval, it usually says, please interpret the confidence interval. But this time we're being asked to interpret a confidence level. What does that 90% mean? And this tends to be a fairly tricky concept for students. So this brings us to our second chance to do a poll. So what I'd like to do here is we're going to interpret that confidence level together. So here come 4 potential interpretations. Here they go. First of all, A, there's a 90% chance the true mean difference in sale price is between negative 18.9 and 19.4. B, 90% of intervals constructed in this manner would capture the true difference between the mean sale prices. C, 90% of similar homes between the two cities have a difference in sale price between negative 18.9 and 19.4. And D, 90% of intervals constructed in this manner would show a difference between, and I'll just say those two numbers. So Mr. Timmons, we're all set for our second poll. Awesome. This one has a lot of reading, so take your time with it. About 70 people who have voted so far. Okay, we'll give it about another 10 seconds.
Just as a side note, Bob, I think we found our winner from furthest attendee.
Yeah, I saw a few Chinas.
We have one from South Sudan.
Oh, fantastic. Well, welcome. Welcome to Kentucky via Hatboro, Pennsylvania.
He said he's taking his test tomorrow at 3 a.m.
Yes, and our friends in China, what time, if you can say in the chat, what time are you taking it tomorrow? 3 a.m. So for our friends in the US here, you may not realize that the times that we're doing it are standard throughout the world. You have to adjust the time zone. So 2 a.m. Thank you for that input. That's fantastic. Okay, so let's end this one. So B is the most often said response, and that is true here. B is the correct answer. But I do want to address a couple of the other ones here. I do want to address A and D. A, there's a 90% chance. So here's the thing with confidence intervals, okay? After you have constructed a confidence interval, the probability that your confidence interval captures the truth is either 0 or 1. It either has or it has not. Now, we don't know because we don't know the true difference between the things. But after we have done the confidence interval, we've either captured it or we have not. However, you can talk about probability with the confidence interval in that before you start sampling and you know you're going to do a procedure and you say, I'm going to do a confidence interval, at that point, the confidence interval that you are potentially going to create has a 90% chance of capturing the truth. But that's only before you start collecting data. Okay. The last one, 90% of intervals constructed. So I like that one. The end part is not so great though. What are they trying to capture? Well, we're trying to capture the true difference. We're not trying to capture what happened in the sample. We've already done that. We're trying to capture the true difference between mean sale prices. So keep in mind that confidence intervals are trying to capture things about populations. Here, that is the true difference between the mean sale prices. So I have a few more thoughts here about confidence intervals and interpretations here. And a couple pro tips actually for confidence intervals in general. First of all, if you're asked to interpret a confidence interval, ask yourself, what did we seek to estimate? And then this one, usually I would say most of the time we are asked to construct and interpret a confidence interval. In that case, we say we are blank % confident the interval captures, and then we talk about the true difference, the true proportion, the true mean, and we talk about it in context. But interpreting a confidence interval is capture rate. In my classroom, there's a big bulletin board with rubber bands that we used in an activity, and those represent the capture rate for confidence intervals. It's how often should you expect to capture the truth. Sometimes we'll get a weird sample that maybe doesn't capture the true parameter, and that's okay. In that case, we want this template. Blank % of intervals constructed in a similar manner. If we were to sample similarly over and over, we would capture the true parameter. Okay. One more piece to this question is a part E. Based on the confidence interval, does the analyst have convincing evidence of a difference in the population mean sale prices in homes between the two cities? Justify your response. So on this one, here's what I'm going to do. I'm going to give you a student response, and you're going to help me grade this one. You're going to give it the E, the P, or the I. So here's the response. The student response says, since 0 is captured by the confidence interval, we can conclude that the true mean housing price for each city is the same. So what I want you to do with this one is, what do you think about this response? This one you're going to grade. It's either essentially correct, partially correct, or incorrect. So Mr. Timmons, we're all set for poll number, I guess this is number 3, right? This is poll 3. There it is. You can answer D, but you'll be wrong. Somebody answered D. Santa's watching, whoever answered D. This one's pretty quick. We already have almost 90 responses. Take 10 more seconds to register your opinion. All right, let's take a peek. So this one, I'm going to show on my screen here. Many of you said B. This one I'm actually torn between B and C. My gut, I would like to grade it as a C, incorrect, but I did find some examples of old AP exam rubrics that maybe would have given this one a partially correct. And partially correct here is actually being quite nice. So let's talk about what the problem with this one is. Let's see what the issue is here, okay? Let's go back to the screens here. So first of all, my pro tip is answer the question that's being asked, not something that's tangential to the argument. So in this one, we want to know, is there convincing evidence of a difference? But this person talks about not difference, but being the same. And it turns out that that subtle difference between proving a difference and talking about things being the same, those are quite different things. So let's go through some things that we want to talk about here. As I get rid of the poll here. So here's the model response. 0 is captured within the 90% confidence interval. That's a good thing. It's a confidence interval of plausible values for the difference in population means. Therefore, this confidence interval does not provide evidence that there is a difference in mean sale price between the two cities. And it might seem like this model response feels like the prompt, the student response I gave you in the last screen. But there's some issues here. So here come your pro tips here. In general, a confidence interval provides an interval of plausible values for the parameter. Here, that's difference between means. If 0 is captured, this does not mean that 0 is the truth. The interval also contains many other plausible values that also could be the truth. So 0, sameness, is not automatically the truth just because it's captured by the confidence interval. But if 0 is not captured, this provides evidence of a true difference between the parameters. Another way to think about it is, if this was a hypothesis test and we wanted to say the null hypothesis here would be the cities have the same mean sale price. And we know, hopefully, whoever you've had this year as your teacher, hopefully they have told you that you should never accept a null hypothesis. You should never accept a null hypothesis. Never, ever, ever accept a null hypothesis. Never, never, never. We should never accept a null hypothesis. So we cannot prove that singular value of 0. We can talk about, we have evidence that there's no difference. That does not automatically prove 0. So be careful of capturing and capture rate between things. That is the end of question 1. I'm going to pause for a second here. Are there any questions about question 1 in general? Any of the concepts that were in there before we move on to question 2? Rob, I see you raised your hand there. If you want to type something in the chat, that's just fine. Or anyone else wants to put a something in the chat? And good luck to you people. Have to get up at 2 in the morning for the AP exam tomorrow. I'll pause a couple more seconds for a question. And Rob, I'm looking for your question. See if it appears. But if not, in order to avoid the awkward silences, we'll also move on. Okay, I'll have my eyes peeled for questions here. Oh, there it is. It's all right to screenshot this, right? Mr. Timmons, I think that's okay?
Yeah, sure, absolutely. And we will also post the recording as well. So
yeah, we're gonna post a recording. And actually, did we put these slides in that folder yet, Mr. Timmons?
yes, the slides are in there as well.
Yeah, so at the end of this, Rob, and this is for everyone, the slides are in a, I don't know if it's a Dropbox or, no, it's a Google folder. So at the end, we'll post that link again. And if you want to take these, and if you feel like you want to make a study guide out of the pro tips here, you're welcome to do that, okay? But yeah, screenshotting is absolutely fine. All right, so let's move on to the second question. So second question is this one. A college researcher wanted to determine how distraction could influence the time required to complete a simple task. To find out, the researcher recruited 20 students to complete a task which required the student to complete a cup stacking task by placing 15 cups into a stacked pyramid shape. And we have a picture there for what it should look like. Each student completed the task twice. One trial was completed in a quiet room, while a second trial was completed in a room where 10 students were paid to cheer loudly for the participant as they stacked the cups. How do you think you would do with that? And a coin was flipped to determine which trial the subject would complete first. After completing their initial trial, the subject then moved to a new room to complete the other trial. For each trial, the time required to complete the task was recorded. Okay, so here comes our first question. Explain why is it necessary for the researcher to randomize the order of the trials for each student? And I'll be honest, these are the type of questions where students start to write strange and interesting things, for lack of a better phrase. And as readers, these are the ones where we really root for students to do well on this, because there's nothing better than a well-constructed response to read and say, hey, this student really got this, because it's very easy to tie yourself into linguistic knots when trying to answer questions like this. So here's some pro tips for this. First of all, avoid fluffy words. So words that just don't have a lot of value unless you follow up with meaning. So things like confounding variables, skewing the results, more accurate. Writing those phrases really doesn't help your argument unless you follow up with something that's more precise about what's going on in the problem in the context. And in this particular problem, and in all problems, think about the response variable. What are we trying to measure here? We're trying to measure the task completion time and the difference between those things. So if your response doesn't talk about the times to complete the cup stacking task, then something's gone wrong. We need to include something about the amount of time it's going to take people to complete the cup stacking task. So here comes a model solution. Without random assignment, it is possible that the difference in task completion times could be due to a confounding variable not related to the cheering students. Now that first sentence is okay so far. There's a difference, but just saying confounding variable is no good. You got to talk about what a confounding variable could be. But here we go. For example, a volunteer could improve their time through experience with the task. Maybe their time goes up or down just because they did it a second time. They got better at it. And randomization evens out the possible effects of potentially confounding variables. So notice we're talking about time on a task, and we've given a possible confounding variable. So be careful of using those words that are just kind of empty phrases. It's very rare you're going to get credit on the AP exam just for giving us vocabulary words. Tell us about the problem. Okay? So always go to the problem, make sure you've read it completely. All right, secondly, B, short and sweet. Is this an observational study or an experiment? And then you have to explain it. But this one will be our fourth poll. So it's your turn here. So Mr. Timmons, we are ready for the next one. Either yes, this is an experiment, or nope, it's not an experiment. I see a question in the chat that I will get to in a moment. Okay, this was pretty short and sweet. Is this an experiment? And ask yourself, why are you thinking it is or is not an experiment? Okay, about 10 more seconds. Almost 90 people. Fantastic participation today. I see a lot of people who seem like they are really in good shape for the AP Stat exam. Okay, you got just about 100 people. There's 100 people. Perfect. 100 votes, 101 votes. And it is this is an experiment. So why is this an experiment? So let's take a peek at it here. So a couple things, pro tips. So first of all, in an experiment, a treatment is imposed. Oftentimes, if you think about medical studies, it means that some people were given a new drug versus an old drug, or a new aspirin versus a placebo. But here we do have random assignment of subjects to treatments. The treatment here being people yelling and screaming at you as you're trying to complete the cup stacking task. That is a treatment. Okay, let me get rid of the poll here. And keep in mind, experiments, we often time to prove cause and effect. So if we see something about cause and effect down the road, we're going to want to talk about that. And we're going to try to generalize to people similar to the subjects. So we have subjects here who are, I think it was college students, right? Students at the college. So we'll generalize to college students, okay? So let me give the model solution here. Actually, I don't have a model solution. So I've noticed I didn't explain it here, but we have subjects who are randomly assigned to treatments, would be the explain why. So we do have a question in the chat here. Can we talk about bias at all? So this question did not talk about bias. I'm trying to think of a place where bias could creep into this, or a way to reword this one. Bias usually is something within the study design that might overestimate or underestimate the parameter of interest here. Let me think more about that one. Yeah, I don't have a bias entry point for this one. Dr. McGuffin, if you can think of one, feel free to chime in on that. But I don't have a bias example here. And I have another question here. Are random assignment necessary for defining an experiment? So the thing that makes something an experiment is imposing a treatment, assigning people a treatment. And in early years for the AP exam, if you simply said that a treatment was imposed, that is sufficient. Now, in a good experiment, we hope that it's done randomly, because we're hoping that a random assignment would filter out the different characteristics of the people within the experiment. So I would like you to say random assignment of subject to treatments, but assigning the assignment, the imposing of treatments is normally enough there. Okay. Okay. Good questions. Great questions here. All right. Next part. Part C. For each student, a coin is flipped to determine which trial is completed first. What is the probability that the researcher does not see the first tail until the sixth coin flip? I'm going to dive right into the model solution for this one, because hopefully this is a fairly basic computation here. But the idea here is that means that I'm going to do heads, 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 and then finally get a tail on my sixth coin flip. Another way to think of it is that means that we're going to fail 5 times and finally get that success of a tail on the sixth coin flip. So let X represent the number of coin tosses needed to see the first tail. Hopefully you recognize here that X is a geometric random variable where P equals 0.5. And the probability we then get our success on the sixth trial is, well, we need 5 failures, then a success. And if you plug that into your calculator, you have that. The reason I'm bringing this one up is a couple of reasons. One, geometric is not something that has been assessed often on the AP Stat exam, but this year teachers were told that it is something that they might be emphasizing more. And then this year, where we're not going to have a whole lot of calculator things besides scientific calculator calculations, it feels like this might be something they could ask you. I don't have any inside information there, but geometrics are fairly easy to do on a scientific calculator and reasonable to do. Within this model solution, you don't need to recognize that it's a geometric random variable. If you were to just write just this 0.5, even just 0.5 to the 6th power here would be sufficient, because that does give the work here. It'd be nice if you knew that it meant that was 5 heads and then followed by a tail, but you don't need to define this one as geometric. You can just do the work here, that's fine. But some pro tips here. My intention of this question was to talk about binomial and geometric random variables. Binomial, pretty much every year in AP Stat shows up in some way, shape, or form. This year, with not having scientific or graphing calculators in front of us, it may be that binomial does not show up, but who knows? But let's talk about the similarities. The similarities that binomial and geometric both have independent trials. We have a constant probability of success, and we have two outcomes, success or failure. The differences are that in a binomial setting, you need so many successes within 10 trials or 8 trials. I want 2 successes within there. That's the classic binomial setting. And in geometric, you fail, fail, fail until you finally succeed. So I would make sure you know the difference between those two things. For those of you who have TI-84 calculators and you've used that throughout the year, I find it highly unlikely that you would have to use something like binom CDF this year, just because that's something that is a calculator command that goes beyond the scientific calculator. And keep in mind, all questions this year are being written in such a way that you could fairly easily do them with pencil and paper and maybe have a scientific calculator in front of you. But maybe you could be asked to identify a binomial setting. That would be reasonable. Okay. Any questions on C there? Because the second half of this question dives into inference. Would it be beneficial to mention why it is not binomial? I would not, that goes to, you mean part C here? I would not get into answering parallel questions. This question just wants you to find the probability. So therefore, I would just stick with the 0.5 to the 5th times the 0.5. Because the problem is if you start saying, here's why it's not binomial, and somewhere within that explanation, you say something that's incorrect, the readers now have to grade that. So make sure you're just answering the question that's in front of you. And Grace asked, do you need to define X? You do not. I would say on this one, if you were to just write, let's see if I can highlight this. If you were to just write out, let me get my little pen here. I'm gonna try to get a pen out. I'll just leave that be. If you just do this part that I'm circling with my mouse here, you're okay. Okay, so we're gonna move on to the next question here. Here comes question D. Good questions. For each of the 20 students, the time required to complete the task in both the quiet room and the loud room is shown in the box plots. In addition, the difference between task completion times between the 2 rooms for each student is given in a box plot. So the researcher claims that on average, college students will complete the quiet room task in less time than the loud room task. State the null and alternate hypothesis the researcher should use to test this claim. Make sure you define any parameters you use. Okay, this is going to be our next poll. And actually, before we do the null and the alternate, I want to work together and I want to name the procedure, because doing the null and the alternate, you need to know which procedure you're going to use, right? So this time we're going to play name that procedure. Here are 3 things you can potentially answer. Either it's a 2-sample t-test for difference between population means, a 2-sample z-test for difference between population proportions, or a paired t-test for population mean difference. Right, Mr. Timmons, we're all set for number 4 here. No, is this number 5, I guess, right? Yes, it's 5. He's got it. He's ahead of me. Yes, our 5th poll, right? Okay, about 10 more seconds. This one, a lot more difference of opinion here between A or C. Those who said B, I will point out this problem is not about proportions. Proportions are percentages of things, fraction of times that things happen. This is not a proportion question. Okay, so this one, I will tell you before I show the answer here that this one, when I wrote this question, I modeled it off of a question, I think it was 2014. And that question did something very similar to this one, where they gave you box plots for 2 things that were related, and then they give you a box plot of the differences. Here's what I want you to think about. Put yourself in this scenario. Let's say you're one of the volunteers, and they put you into the loud room, and in the loud room, you're able to complete the cup stacking task in 28 seconds. And then you're put into the quiet room, and you're able to do it in 25 seconds. So 28 seconds here and 25 seconds here. Those 2 numbers are important, 28 seconds and 25 seconds, but what I really care about is it took you 3 seconds more to do one rather than the other. What I really care about is that difference. And that's really the number that I'm looking for here, because my claim, and you might want to read the claim here in the screen, is on average, college students will complete the quiet room task in less than the loud room task. And every student did both of them. And in this case, it makes sense to subtract their responses from each other because they are dependent on each other. You have pairs of numbers that are dependent. So in this one is C. It is a paired t-test for population mean difference. Those of you said, hey, you're not unusual. The year that they had a question like this, I would say it was pretty much split 50-50, that many students thought it was a 2-sample test versus people saw it as a match pairs test. This is definitely a match pair scenario in that every subject is generating 2 numbers. It makes sense to subtract them. We don't have 2 separate things going on. I'm going to show you the null and the alternate in a moment here, and we'll talk more about this one. So this one is a paired t-test for population mean difference. Means everything we're going to talk about is for population mean difference. Okay. So I see a couple questions in the chat here. So let me show you the null and the alternate, then we'll come back here and we'll take the questions there. That means we're only looking at the differences. That means we are not looking at those 2 box plots of the individual differences. So let's see what's going on here. Here's the model solution. Null hypothesis is mu sub d equals 0, that the true differences is 0, versus we think it's less than 0 here. And where Q, and actually I'm looking at that now, I think it's supposed to be greater than 0, so excuse me here. I believe this is supposed to be greater than 0, because I did quiet room minus loud room. That should be a greater than symbol, so I did the wrong symbol there. So the quiet room should be taking longer, therefore the differences should be positive. So a small little typo there. But mu sub d represents the population mean difference in task completion times. So notice only one parameter, and we're only looking at the differences. So let me take a look at what we have in the chat here. Might they try to trip you up with that difference of means? Well, they did in 2014. This is a very similar question to one that was given about cars in 2014. Could you call it a dependent t-test? Yeah, I think I'm okay with that. Dependent t-test. That seems to get to the idea of pairs. I think I'm okay with that. Dr. McGuffin, if you want to chime in there, I think I'm okay with dependent t-test. And it's because they are the same person. That's why it's a paired test. I think I'm okay with dependent t-test though. Paired t-test is another way to say it. 1 sample t-test for match pairs. We're okay. Okay. Yes, and someone else is saying, could I switch the sign around and make it loud room versus quiet room? Yes. So you have to think about, what do I want these differences to be? And according to this, so here's 0. If it's, yeah, and I think I have a couple. I remember when I did this one, some people pointed out to me I had some inconsistencies with how I drew it here. So we'll ignore those for now. But if we suspect the quiet room takes longer than the loud room, we're going to look for positive differences here. So I have a couple of little misprints going on here. So forgive me for those. But let's move on to E. What is the name of the inference procedure? Well, we did that already, and we want to verify the conditions are met. So let's take a look to see what's going on. So in the model solution, we know the researcher should use a 1 sample t-test for population mean difference. It is paired data. In this one, we should be looking at a random condition. Here, the subjects were volunteers. They were randomly assigned to which task was completed first. So notice, we do not have independent random samples. We do not have that. We have subjects were randomly assigned to treatments. That is the randomization here. In fact, talking about SRSs here would actually be incorrect. We have subjects randomly assigned to treatments. Okay? The normality condition. The normality condition for this one will be our last poll of the day. We're going to do one last poll together. Let's talk about the normality condition. So let's bring back the stuff we were given before. And let's say it's your turn. How is the normality condition satisfied? You have 4 options. A, the box plots for both loud and quiet rooms are both roughly symmetric. B, the box plot of the differences is roughly symmetric with no outliers. C, you think both A and B need to be checked and they're both okay. And D, the total number of observations was 40, which is greater than 30, so the CLT applies. So, Mr. Timmons, we are ready for the last of our polls. Thank you, sir. Ooh. I will admit, I've given you some really tricky questions within the chat here today. I hope they got you thinking about what needs to happen and some of the mechanics behind what goes on here. Dr. McGuffin did chime in and say dependent t-test seems to get to the idea. It's not incorrect. Dependent does convey pairs. I think we'd be okay with that. Notice we have B and D here. B and D are very popular. Okay. I do see something in the chat about the random digit table. I'm going to hold off on that question until the end of this question, if that's okay. All right, here we go. Which one is it? This one, it is B for this one. So keep in mind what we're doing here. We want to check, we already said that we want to look at these differences. We don't want to look at the two independent samples. We're really only interested in the differences, therefore our check for normality needs to be of the differences. And the total number of observations was 40. That's kind of misleading because we actually only have 20 differences to look at. There were 20 people, there's 20 people who did the loud room, 20 people did the quiet room, but then we subtracted those things. We have 20 observations of differences. We want to focus on the differences here. Okay? And I think it's very reasonable this year they might talk about somehow looking at conditions this year. Okay? And I went out of my way here to give you a question that was pretty tricky the year they gave it. This was a one sample test. You need to look at the single set of data. I recall this year they gave it, so keep in mind that regular AP questions are graded out of 4 points. If you did it as a 2 sample test rather than match pairs, you couldn't get more than a 2 on the question, even if you did everything else perfectly. So you need to be able to tell which is the correct type of question, what type of procedure rather. Okay, almost done. Let's get, so it is B. So let's get to the end here. We have a p-value for this one. That is 0.0035. Based on a p-value, what should the researcher conclude? Very typical question for us here. A couple pro tips. First of all, hypothesis tests are like court trials. You are innocent until proven guilty. So think of them like court trials. We're trying to gain evidence of guilt here. And we assume the null is reasonable until we have compelling evidence to move away from it. And low p-values, low probabilities, provide that compelling evidence. Conclusions often have 3 parts. The linkage of p-value to alpha, making a stats decision, and doing a contextual decision. So here's our model solution. You've seen this before. Because the p-value is lower than any reasonable significance level, please list one, like 5%. We have convincing evidence to reject the null hypothesis in favor of the alternate. We conclude that on average, similar students would complete the quiet task in less time than the loud task. That'd be a good model solution here. We have all the pieces. Always go back to the problem and mimic what they are asking us to do. Okay. One last little piece though, I did add a slide today. I was thinking more about this. Would it be reasonable to conclude that the noisy room, or is it loud room? I forget how I said it before. I think I said loud room, caused an increase in cup stacking completion times. So let's take a look here. Some pro tips here to end today here. Pay attention to how the data is collected. Random samples, that's an observational study. But if we have random assignment of subjects to treatments, we have an experiment. And experiments are attempts to show cause and effect relationships here. And we did have a random assignment of subjects to treatments. We have a low p-value. So model solution here could be that because the subjects were randomly assigned to the order of the treatments and the results are statistically significant, it is reasonable to conclude that the noisy room caused an increase in mean difference of reaction times because we had an experiment here. And that is reasonable to conclude here. Okay, any more questions about this one? I do have a question about random digit tables. I'm going to hold off till the end on that one. Any more questions about this particular question? Which was kind of, had a lot of tricky thinking going on it. Okay. All right, about 10 minutes left, and then I'll stay for questions and things from the gallery here. Tips for taking the 2020 exam. So if the p-value is less than 5%, we reject the null. Yes, that is usually the, so I got some questions in the chat now. Let me get to these guys. So if the p-value is less than 5%, yes, that is an unusual result. We did not go over interpreting p-value within this session. That's something you might want to look at here. That does mean that our results are unusual if the null is true. Since in an experiment, we don't have to check that 10% condition. That is true. We do not have to check for a large population. Our subjects are volunteers. If you had the wrong null hypothesis written in major conclusion based off the wrong one, you still get credit. So there's a lot of tentacles to that question. I'll just say that usually if you're logically consistent, we will not double ding you for things that you did earlier. So if you give us a correct conclusion to something that was flawed earlier and it makes kind of sense, we will usually give credit for that. And Nick, I'm going to hold on to your question for a minute because I'm going to address that here in the tips. Okay, so some tips for this year, and I'll stick around for more questions. First of all, context, context, context. If nothing else, please make sure you write context. If the problem is about washing machines and your writing needs to somehow be about washing machines, make sure you're talking about context. Avoid fancy, empty language, things like confounding, bias, and accurate. They really don't help your argument unless you tell me what they're about. In fact, you can give a compelling explanation for something in a stat test without using those words. In fact, adding them sometimes causes trouble because maybe you use one in a wrong way, so be careful. First of all, and then show work. Calculations without work are naked answers and rarely receive full credit. This next one, I call this blah, blah, blah syndrome. Answer the question, then move on. I've had students in the past who they answer a question very well within their first two sentences, and then they feel compelled to write more. Once you've answered the question and you feel like you've given a complete response, put your pencil down or stop typing. Sometimes you fall in trouble, get into trouble by doing that. And if you write something later that's incorrect, then I need to grade that incorrect answer. And that often causes trouble. So make sure you're answering the question that's being asked to you. Okay. Interpret the results of inference to populations. Likely you'll be asked to interpret a confidence interval and or a hypothesis test result. Make sure you're referring to populations. Okay. I have a couple more tips in the next screen. Use proper symbols and be able to type them if needed. The College Board gave a guide for how to type these things. If you're going to type out things like H0 and then U_A, we will take things that seem to mimic underscores and things like that this year. There is a guide on the College Board site that helps you with typing for this year's exam if you choose to type it. Know how to submit. Do you plan to copy or paste, or do you want to upload a picture? Rehearse it on the College Board site. There is a place there you can rehearse. Manage your time. Don't get bogged down by a tricky part. Move on and come back. And most of all, don't worry about the things you don't know. The AP exam is not designed to reveal things you don't know. Rather, do well on the things you know how to do, knock those questions out of the park. Somebody asked about what it takes to get a 3, 4, or 5. I'm going to give you this answer, but then I'm going to put an asterisk on it. Many years you need only about 70% correct for a 5, about 55% correct for a 4. This year we don't know. This year's exam is different. We don't know how it's going to be scored. We won't know until June. So I don't know if those things are going to stay for this year. So I really just don't know. And then finally, show your readers your awesomeness. Show us what you've learned over the year. Okay. As I was doing these slides, I noticed there were a lot of questions that were popping up in the chat, and I'm going to kind of scroll back. I kind of eyeballed them a little bit here. So let me go backwards here. So someone asked about the 10% condition. So the 10% condition is if you're randomly sampling in a hypothesis test, you should be sampling from large populations, and you should verify or understand that the population should be large, at least 10 times as large as a sample. Okay. Linear regression, I do not have any linear regression today. I don't know if they're gonna be on the test or not. They are eligible to be on the test. And like cumulative relative frequency, there's a lot of things that are eligible to be on this year's exam that we just did not do within this presentation. Okay. Mr. Timmons, do you see other questions that seem compelling that I kind of, oh, the one about the random digits I do have to get to. I mentioned that a couple times. Let me talk about that one. Where did they write it here? When using a random digit table, when encountering a repeated number, do we skip that number and keep going till we see the next number of successes? So in general, whenever you are doing a simulation using a random digit table, you should always skip duplicate numbers. So if you are assigning people using randomization, you should ignore repeats in whatever method you're using. Okay. I see a couple other questions here. How many parts would the free response questions have? We just don't know. A lot of people, so we seem to think that maybe one of them will have 5 or 6 parts and the others 4 or 5. Again, we just don't know. The College Board did release a sample item that is meant to mimic the 15-minute question. That question had 4 or 5 parts to it. So I'm going to say 5 or 6 for the longer one, 4 or 5, but I'm just not sure. We just don't know. It's a different year. I will tell you, I would not worry about a table of random digits. You can have one within your things. If they were to give you one, they would give it to you on the exam, but keep in mind, they're not going to have you draw on the exam. So I'd find it highly unlikely that a table of random digits will be on the exam. Still scrolling through other things. Yeah, there's some things that we did not do today. There's a lot of things in the AP curriculum that we did not do today. Can we go over to 3 types of histograms? I will be honest, I don't know what 3 types of histograms are. I know of histograms. If you can embellish that question, I'll be happy to answer. Yeah, John, I'll go back. John wants me to go back here. Some people want to take pictures of that. Awesome. And I did see earlier that Mr. Timmons wanted to, He showed where they were going to be put there. You're welcome. So I have a private question here. That's good. That's worth talking about here. So kind of dumb. This is not a dumb question at all. It's a great question. Why is it so important to check for normality before doing a t-test, before doing a test? Well, here's the deal. Keep in mind, p-value. Down the road, you find that p-value. The probability of getting the results you get in a data collection activity, given that the null is true. Well, the way you find that p-value is from a normal calculation. We assume that on average, the results are going to cluster around the null hypothesis, but natural variation is going to move them all around. And the way we do that, p-value is really a normal distribution calculation. And we need to have a normal distribution in order to do that. That's why it's so important. Okay. If we are not sure of a certain answer, can we answer out of order if we label a question? Yes, you can answer in any order. As a reader, it'd be nice if you were to place them in order when you're done. That'd be awesome. But you can put them out of order. We'll find things. How do we know how to use match pairs? If your data is paired in some way, like if you take a pre-test and a post-test for the SAT, it makes sense to subtract those numbers from each other. That would be a match pairs. So if every subject does both treatments, that's match pairs. If you have, for example, a field, and you take a part of the field and you take a little plot, I don't know if you can see what I'm doing with my hand here, and you put one seed here and one seed here, and they're different from each other, well, that's match pairs because they're on the same plot of land. It makes sense to see the difference between how they grow. For texting the answers for the symbol for the true population proportion, we should type, it really doesn't matter, Ian, there. Anything any type of P we will take. I think capital, it's usually lowercase p, but if you give us a capital P, I don't think that we would go crazy there. Anna asked, do we know if we could send both Codswore photo of written work and a screenshot of something I type out? Anna, I've come to understand, I think you can only give one thing, but don't quote me on that. I would direct you to go to College Board and clearly read their directions for how to do it. I think you have to give it in one thing. I've been telling my students, I think the best way to go is to type everything out and copy and paste it. I think that's easier to do. Hayon asks, are we checking normal conditions for sampling distribution or population distribution? Very good question. So when we check the normal conditions, we're looking to see how the sampling distribution might behave. If we sampled over and over and over again, what would we expect to happen? And that's called the sampling distribution. These are great questions. Mr. Timmons, I'm happy to sit here and just be peppered with questions for a while.
Go ahead. I do think I've seen lots of responses from students that have taken other AP exams last week and this week that you should not expect to necessarily finish the exam. I think they were written in such a way that you can still do quite well if you don't finish the entire question.
Yeah, I've heard that. I heard the calculus one had maybe 8 or 9 parts for one of the questions. And I don't know if that's unusual for them or not. I get that impression too. They're going to try to keep you busy. Yeah. Yeah. So we just don't know how many they're going to be. Yeah. Yeah, there's more questions. By the way, Nathan, why you ask me questions all the time? Nathan's one of my students, by the way, here. Since we don't need the 10% rule for experiments, what would be the ideal response for the independence condition for experiments? You don't need to address it, Nathan. I'll address it here, but you don't need to say it on the exam, but you're hoping that individual subjects from person to person, that they are independent of each other. I mean, that's really what it is, but you don't need to go down that rabbit hole. For an experiment, it's random and normality.
Bob, there was one question about clarifying when you would do a z-test versus a t-test, and that was back in the comments a little bit earlier.
Okay, so there is such a thing as a z-test for means, and I used to teach it. It is actually not part of the AP Stat curriculum anymore, but it's worth discussing. A z-test, well, let me do it the other way. A t-test for means, the reason we use a t-test is when we sample, we don't know the mean length of the fish in the sea. That's why we are scooping fish and we're measuring them, and we're trying to estimate the mean length. Well, if we don't know the mean length, we also don't know the standard deviation. And if we don't know the population standard deviation, we need to use the sample standard deviation instead. And when you use the sample standard deviation, you get a new distribution that is more variable than the normal distribution, and that's what the t-distribution is. So we're trying to estimate a mean, and we're using the sample standard deviation to do that. If by some miracle we happen to know the population standard deviation, then it would be a z-test. But we don't normally know that. So we don't do z-tests for means. And you don't have to do a z-test for mean. When checking conditions for 2 sample tests, it's important to say that the samples are independent. So 2 sample tests, the part there's two pieces to that question. You need independent random samples, and the independence part, and we started checking this more last year, is both samples need to come from large populations. So for example, let's say you take random samples of 20 freshmen and 20 seniors at your high school. You need to have at least 200 seniors and at least 200 freshmen at your school. That large population condition you do have to check. Okay. Why do we need CLT in large counts? Well, the central limit theorem says that if you take large enough samples, the sampling distribution of the sample mean will become approximately normal, that they will gravitate towards the true mean and you will have a normal distribution. So CLT gives us normality in the means problem. Are type 1 and type 2 error going to be on the test? I don't know what's going to be on the test, but they are certainly eligible. They are eligible content for the test. There are a number of questions out there about that. Can two sample tests have two samples from the same population? Ooh, two sample tests have two samples from the same population. Dr. McGuffin, you want to address that one? I can't find it. I got to think there's a way that you could, but I think that would be unusual. You're usually comparing two populations when you do that. You're going down some rabbit holes there. Usually from two separate populations.
I can't think of an example on any of the ones that I've scored that in which that's been the case.
Yeah, if somebody was really crafty, maybe you could write one, but I would not stress over that. If we're checking a 10% condition and we don't know the population size. So here's the deal in the AP exam. Oftentimes you will see them say things like, we take a sample, there's a large college and we take a random sample of 50 students. Well, the reason they're saying the word large, that may seem like a throwaway word, they're giving you a safety net to say, oh, we can assume that there is a large number of students at this college. So oftentimes you can assume a large population when you're randomly sampling, but look for those buzzwords like large that don't seem like they're important at the time, but they're there for a reason. Overall, do you think we'll be given calculations and have to interpret? Yes, I do, Stephanie. I think you'll be given p-value or confidence intervals and have to interpret. I think that's what's going to happen. Mr. Timmons, I do have to say, I actually have another Zoom that started at 3. So I'm going to take 1 or 2 more questions and then it's time to wrap it up.
Yeah, go right ahead.
Yeah, awesome. You assume a large enough population, the problem doesn't state it. Yeah, I would, but I'd also have some safety that somewhere I would have enough background information to be able to make that assumption that we have a large population. So like a large lake and I catch 50 fish. Well, a large lake means there's probably over 500 fish in the lake.
And just a quick note for those of you that asked about tests for proportions and for type 1, type 2 errors, there is on KY AP 2020, there's a study session on tests for proportions that talks about that in more detail. And so that would be a good review for you to go back and watch.
Awesome. Hey folks, you are a wonderful audience and I wish you all luck on tomorrow's exam. So many great questions today. And take care of yourselves. And there's a bunch of links there on the screen that you can use. Good luck tomorrow.
Thanks, Bob. I think this was super helpful to students as they get ready for the AP exam. Just a reminder, all of these handouts along with the videos from today's session as well as all the other ones can be found at kyap2020.com. Just go there, there's a math tab and then find statistics, and we'll post that video just as soon as it gets uploaded and processed. So if you have questions for any of us, myself, Dr. McGuffin, or Bob, feel free to email us, shoot us a Twitter follow or a Facebook follow. And then tomorrow, 2 p.m., it is the AP exam, so best of luck. Sherry, Bob, any closing remarks? And if not, we'll go and sign off.
Just good luck to everyone.
All right. Well, thank you all so much. Again, we wish you the best of luck tomorrow. So with that, we will go ahead and sign off and see you all later. Take care.